Hello, welcome back again. Today we're going to talk from Geometry Section 3.2, Angles and Parallel Lines. Start with some properties of parallel lines. Corresponding angle postulate states if two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. Here we have the diagram showing angle 1 and angle 2. Seeing as how angle 1 and angle 2 are corresponding angles as we've previously defined in our previous lecture, angle 1 and angle 2 then are congruent. Along on this theme, we have the alternate interior angles theorem. If two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. Our example, 3 and 4 are alternate interior angles, seeing as how the lines that are being transversed are parallel. Angle 3 and angle 4 are congruent. Along the same line, consecutive interior angles theorem states if two parallel lines are cut by a transversal, then the pairs of consecutive interior angles are supplementary. And again, our picture here, we have angles 5 and angle 6 being consecutive interior angles, so therefore then by the theorem, the measure of angle 5 plus the measure of angle 6 equals 180 degrees. Alright, finishing up the properties of parallel lines, we have the alternate exterior angles theorem, which states that if two parallel lines are cut by a transversal, then the pairs of alternate exterior angles are congruent. Our example has angle 7 and angle 8 as being alternate exterior angles. By the theorem then, we have, since we have two parallel lines, we know that angle 7 and angle 8 are congruent. Lastly, we have the perpendicular transversal theorem. If a transversal is perpendicular to one of the two parallel lines, then it is perpendicular to the other. Our example, we have line J perpendicular to K. If line J is perpendicular to H, jumped ahead here. If we have, back to the picture, if line J is perpendicular to H, then we also have J perpendicular to K if H and K are parallel. Alright, let's apply these examples then. Alright, proving the alternate interior angles theorem, we have given that P is parallel to Q, and we want to prove that angle 1 and angle 2 are congruent. So we start with the given always, with our two column proofs. We have P parallel to Q, and we have the reason as given. Now taking a look at our picture here, we can use the angles as reference when we're taking a look at the proof here. I want to show that angle 1 and angle 2 are congruent because that would prove the alternate interior angles theorem. However, I can't use that. I can, however, use other theorems that we know to be true to prove this. So if I take a look at, for instance, the relationship between angle 1 and angle 3, we note that those two angles are corresponding angles. So therefore then, since P is parallel to Q, and that was given, I can say, or we can say, that angle 1 is congruent to angle 3, and the reason for that is a corresponding angle postulate. Okay, since angle 1 and angle 3 are corresponding angles, then they are congruent to each other. Okay. Now that we've taken a look at the angle relation between 1 and 3, we can also note that the relationship between angle 3 and angle 2, okay, would be a vertical angle set, and we know that vertical angles are true. So therefore we can state that angle 2 and angle 3 are congruent by definition of vertical angles, okay, or the vertical angles theorem. Alright, we know that they're vertical angles, so therefore they're congruent to each other. And if we're trying to show that angle 1 is congruent to angle 2, and I know that 1 is congruent to 3, and 3 is congruent to 2, then I can say that 1 is congruent to 2 by the transitive property. Okay, and this is the transitive property of congruence. Okay, because we're talking about two congruent angles here. So again, using trying to prove the alternate interior angles theorem, we have to solve that using other theorems than the alternate interior angles theorem. Okay, and we have our proof that follows. We can do a similar proof for the the alternate exterior angles theorem, and the consecutive interior angles theorem, etc. Alright, next one. Okay, speaking of consecutive interior angles theorem, we have a proof that says if P is parallel to Q, prove that angle 1 and angle 2 add up to 180 degrees. Okay, first of all, locating where 1 and 2 are, we have angle 2 down there and angle 1 up on top. Okay, start off with the given. I can attack this from a number of different ways once I have P parallel to Q, reason given. Alright, noticing a lot of information up there. We have a lot of measured angles. If I can define an angle relationship that somehow connects 1 and 2, I'll be able to make the relationship that 1 and 2 equal 180 degrees. Okay, so taking from the diagram and knowing that I have parallel lines, we can state that angle 1 and angle 4 are congruent. Okay, why can I make that statement? Let's take a look here. Angle 1 and angle 4. Okay, knowing that P and Q are parallel to one another, and 1 and 4 are alternate exterior angles, we can say then by the alternate exterior angle theorem that those two angles are congruent. Okay, it's nice that we have those two angles congruent. Once we have the angles congruent, okay, we should be able to make the statement, or we can make a statement that says that the measure of angle 4 plus the measure of angle 2 equals 180. So we have angle 4 here and angle 2 here. These add together give you 180 degrees. Reason for that, definition of a linear pair. 2 and 4, those two angles add up to 180 degrees because they are a linear pair. Linear pair implies supplementary. Okay. Now I have a statement that has the angle 4 plus angle 2 equaling 180. I have another statement on step 2 where it says angle 1 is congruent to angle 4. So if things are congruent to each other, we know that they have to be equal to each other. So congruency implies equality. Okay, and equality then is what we have here. Measure of angle 1 equals measure of angle 4. Reason, definition of congruent angles. And if 1 is equal to 4, I have no problem substituting what 4 equals with 1. Right? I can just substitute 1 up there, and I'm reading my statement 5. Measure of angle 1 plus measure of angle 2 equals 180 degrees. Again, reason, substitution property of equality. I'm replacing the values that I know in there. Okay. There are other ways to solve this problem, and as long as they follow deductively as this one did, we're set to go. Alright, using properties of parallel lines. Given the lines are parallel and measure of angle 2 is equal to 110, find each of the following measures and state the postulate or theorem used. So I'm looking for the angle measures of 8, 1, 3, and 4. Okay, given that P and Q are parallel, the two lines, and that angle 2, it says, is 110 degrees. So we're going to say that this is 110 degrees. Okay. How do I show then the measures for each one of the angles? We got to figure it out. I have a relationship looking at 8 and 2, okay, between 8 and 2 here. Okay, this would be a linear pair. I know that linear pairs add up to 180 degrees, so therefore I know that the measure of angle 8 is 70 degrees. Okay, and again, linear pair postulate would be the reason because we have a linear pair set up there. Okay, going through. Taking a look at the measure of angle 1 then. I know that we have the measure of angle 1 and the measure of angle 8 in the same spot. So if 8 was 70 degrees, then we know that 1 has to be 70 degrees. And the reason 8 and 1 are in corresponding spots, therefore, by the corresponding angle postulate, the measure of angle 1 has to equal 70 degrees. Alright. Looking at the measure of angle 3 now, going back here, I know that the measure of angle 2 was 110 degrees. Taking a look at the relation between angle 3 and angle 2, those two angles are alternate exterior angles. If the alternate exterior angles are within parallel lines, which P and Q are, we know that then they are congruent, so angle 3 has to be 110 degrees. And that again was by the alternate exterior angles theorem, okay, that they are congruent and the same. Lastly, we have angle 4 looking for the length of. or excuse me, the measure of. And 4 and 2 have a linear pair relationship here, so that means they are supplementary, so therefore 4 has to equal 70 degrees. We also know that 4 and 8 are vertical angles, so also by the vertical angle theorem we know that 4 has to be 70 degrees as well. So either one of those will work to solve for angles 8, 1, 3, and 4. Okay, again, applying the theorems that we know about parallel lines. Alright, next one, using that same information in the figure, measure a angle 11 equals 51. And we were trying to find the measure of angle 15. There's an error there. Okay, going through. If we know, we can show that though, if we had the measure of angle 11 here being 51. Okay, we also know that the angle 15 will be 51 going through as well. Okay, so that is true, even though the part got cut off there. Next example, or next question. In the figure, measure of angle 11 equals 51. Find the measure of angle 16. Okay, we know that we have 16 here, and we have angle 11. Angle 11 equals 51. Angle 16 also then equals 51 by the alternate exterior angle theorem. Okay, so that, again, that's just applying the rules that we had before. Next example here says the diagram represents the floor tiles in Michelle's house. If the measure of angle 2 was 125, find the measure of angle 3. So we have the measure of angle 2 being 125, and we're looking for the degree measure of angle 3. Well, if we notice, we have parallel lines. 2 and 3 would be alternate interior angles. So therefore then they're congruent to each other, and if they're congruent they're equal to each other. So therefore then we know that the measure of angle 3 is equal to 125 degrees. Okay, alternate interior angles postulate. Next question. Diagram represents floor tiles in Michelle's house. The measure of angle 2 is 125, and now we're looking for the measure of angle 4. Well, we just determined that the angle measure for 3 is 125, and if we look at the relationship between angle 3 and angle 4, these are a linear pair, so therefore then we can just subtract from 180 and we'll end up with 55 degrees as the measure of angle 4. Okay, and that would be answer B going through. So we're just applying that information to the diagram. So we have two types of problems we've kind of covered so far, and those are the types of problems that we're going to end up on the quiz and also in class. Questions of proving statements, and then also using the angles to solve for other angles in a diagram. Alright, adding algebraic expressions to the ideas of angle congruencies. Okay, with parallel lines. Says if the measure of angle 5 is equal to 2x minus 10, and the measure of angle 7 is equal to x plus 15, find x. So first of all, we need to denote the relationship between angle 5 and angle 7. We have angle 5 here, we have angle 7 there. Given we have P and Q are parallel, so that means 5 and 7 are corresponding angles. If they're corresponding angles, we know that they're congruent, and if they're congruent, then they're equal. So we can go ahead and go through the list here. 5 and 7 are corresponding angle postulates, they're congruent to each other. They're equal, definition of congruent angles. We know then by substitution we can take what 5 equals 2x minus 10 and what 7 equals x plus 15, substitute those values in, and then it's just an algebraic solve for the value of x. We go ahead and subtract x from both sides. We're going to go ahead and add 10 to both sides, and we're left with x is equal to 25. Okay, same idea with the problem, we just threw an algebraic expression in there and solved. Alright, same type of problem. The measure of angle 4 is equal to 4 quantity y minus 25, and the measure of angle 8 is equal to 4y. Question, find y. So we have the measure of angle 4, and we have the measure of angle 8. Now there is not direct association between angles 4 and angle 8. However, we do know that 4 and 6 are a linear pair, okay, because we do have these two angles equaling a linear pair. And then we know there's a relationship between angle 6 and angle 8 by corresponding. Okay, so we know by corresponding angles that angle 8 and angle 6, so if we can say that angle 8 is angle 6, then we can set those two expressions equal to 180 and then solve. So 8 and 6, as it states, are congruent because of corresponding angle postulate. If they're congruent, then they're equal. If they're equal, okay, I can use the values that they have that are equal to each other. We know that 4 and 6, okay, have to be supplementary because of their linear pair. So we have, after we substitute the value 4y for measure of angle 6, we know that we have measure of angle 6 plus measure of angle 4 is equal to 180. We can substitute in what angle 6 and angle 4 are equal to. We have this statement then, 4y plus 4 quantity y minus 25 equals 180. Now that we have this set up, it's an algebraic solve again for the answer for y. Okay, distributive property, add 100 to both sides and combine the two 4's. We combine the two 4's to make 8y. We'll divide both sides by 8 and we're left with y is equal to 35. Just went too fast there. Y is equal to 35. Final answer. Alright, using parallel lines properties. Okay, same type of idea that we have. Alright, use properties of parallel lines to find the value of x. So if we know, we're assuming that these two lines on both diagrams are parallel, find the value of x. Okay, the number 1 here on the left and the number 4 here are just used as references that we can use those angles, angle 1, angle 4. We know we have a vertical angle pair there, so therefore angle 1 is equal to 72 degrees. Seeing as how the lines are parallel, we know that these two angles on that transversal there are supplementary, so that x minus 8 plus 72 is equal to 180. Okay, here showing that the measure of angle 1 is equal to 72 by the vertical angles. The two angles added together equal 180, substituting in 72 for 1. Okay, and then solving. We go ahead and subtract 8 from the 72 and then subtract over the entire value, leaving us with x is equal to 116. Similarly, on the right then, we have angle 4 and angle 125 being the same spot. We're going to bring 125 down by the corresponding angle postulate, 125 degrees here. We know that these two angles have a linear pair set up, so therefore they equal 180 degrees. Solving, measure of angle 4 is equal to 125 by the corresponding angle postulate. Measure of angle 4 plus x plus 15 equals 180. 125 plus x plus 15 equals 180. Solving, then we're left with x is equal to 40. Alright, using similar styles here, we have the measure of angle 1, 2, and 3 all equaling an expression. We want to find x in this first question. So we note that we have x values in the measure of angle 2 and the measure of angle 1. And we know that the measure of angle 1 and the measure of angle 2 are congruent to each other because lines AB are parallel. And this is our transversal, line C. So just concentrating on the red lines, we can say that the measure of angle 1 is equal to the measure of angle 2. So therefore, solving, we would have 9x plus 6 is equal to 10x minus 6 after we distribute here. We would go ahead then and subtract 9x on both sides, and we have x is equal to, after we add 6, to 12. Okay, so solving through, we'd have x is equal to 12. Alright, finishing the second part of this, we need to find the measure of angle y. We found the measure of, not a measure of angle y, just y the variable. We found x the variable in the previous example. Okay, going through again, we found that measure of angle 1, measure of angle 2 are congruent to each other. Okay, so we said that at 9x plus 6 was equal to 10x minus 6. We solve for x is equal to 12. If we replace what 12 equals into the measure of angle 2, okay, Okay, we end up with the measure of angle 2 equaling 2 times 5 times 12 minus 3. So we had two quantities, 60 minus 3. 60 minus 3 is 57, and 57 times 2 is 114. So if we have 114 for the degree measure of 2, and the relation between 2 and 3, now that we're looking at line C, line D in this transverse, so the green lines, we know that angle 2 and angle 3 are corresponding. So then by corresponding angle theorem, we know that the measure of angle 3 is equal to 114. So we can take 114 instead of equal to what the measure of angle 3 equals, which is 5y plus 14. So we have 114 is equal to 5y plus 14. We can subtract 14 on both sides, and we're left with 100 is equal to 5y, and when we divide, we're left with y is equal to 20. So therefore our final answer then will be the letter B. Okay, so we have this multi-step question here where we first had to find the value of x so we could find the value of angle 2, and once we knew the value of angle 2 we could find the value of angle 3, and then once we knew that we could solve for the specific variable that we have for the expression for angle 3. Okay, and again, both types of problems, this application problem and the proofs, will be on the test. Alright, this concludes lecture then for today. Practice problems that we're going to cover and talk about are from page 181, numbers 1 through 37, the odds. Thanks for watching.